Welcome back to this new video about linear programming, the maximization problem, and here we're going to draw the inequalities and the feasibility zone. So this is still a part of our course masterclass in project management, and we're looking deeper into linear programming, integer programming, and projects. The thing we're going to do here is about drawing the inequalities. We determined the inequalities in the previous video, so if you want to review that, you can go back to that video and see how we got to those equations. We're going to draw the first equation, 4.5x plus 6 times y smaller or equal than 1440. The second equation is 1.5x plus 3y smaller or equal than 600. And then we have the limitations, x smaller or equal than 300, y smaller and equal than 175, and the two non-negativity conditions, x and y larger than 0. So let's start by finding the feasibility zone or the acceptable zone for the first inequality. So we have our x and y graph. We're looking at the first equation, and what we're going to do first is we're going to find the x-intercept. So the x-intercept for the line 4.5x plus 6 times y equals to 1440 is 320 and 0. We do the same for the y-intercept, and the y-intercept is 0 and 240. And now we can draw the line between those two. So the line itself contains the equality. So the points of the line are also part of the solution. And I color the zone which is not compliant. So basically, when you put there 0, 0, you see that the part below the line is compliant with the inequality. This is a way I do it because it will show us a clear zone and we don't have to look at all the colored parts combined. And the feasibility zone which remains in this case is basically, when we draw it on a white paper, the remaining white zone. The next thing to do is to look for the second equation. So the second equation, which is 1.5x plus 3y smaller or equal than 600. So we have this equation here. We also have the x-intercept 400 and 0. We have the y-intercept, which is in this case 0 and 200, and we color the part that the part below is compliant with the solution, so I color the other side. And the last thing we have to do is to draw the conditions, the limitations, x smaller or equal than 300, y smaller or equal than 175, and of course the non-negativity conditions. So let's first have a look at x smaller or equal to 300. So it's a vertical line, x equal to 300, and it's the right-hand side which is not compliant. So the left-hand side is part of the feasible zone for this line. We do the same for y smaller or equal than 175, and again we find the lower part to be within the conditions of this inequality. The two remaining parts are the x and y non-negativity conditions, so we also eliminate the part below the x-axis and the part to the left of the y-axis, and we find this, in this case, light green zone being the feasibility zone. And that's basically what we have to do to start with the next process, which is determining the optimal solution. That's it for this video. We will continue in other videos to resolve the problem. We want to find the optimal point, the optimal combination of x and y. That's it for this video. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.